I'm not going to start on this triangle. I'm not going to start on the right triangle because it has an unknown angle in one side, but I need one more bit of information. I need 3 pieces of information. On this side, you can use SOHCAHTOA, and you would start on the side because you now have 3 bits of information. That's one way of doing the problem. You can use the opposite over the hypotenuse. You can use sine of 30 equals W over 6, solve for W, and then use W. You can use the inverse, so that would give us the inverse of cosine of W over 4 to give you X. But I'm going to present a different way. So if I were doing the problem, because I already know the one big clue is this 30-degree angle. And how can I use this 30-degree angle? Class, what am I making? What type of triangle? What type of triangle? An equilateral triangle. Class, why am I doing that? Because this is 6. This is, and the whole length of this has to be 6. So if you cut that in half, the answer is 3. Now, raise your hand if you saw that. Okay. Now, if you didn't see that, again, the old school would have been sine of 30 degrees equals the opposite side, which is W, over the hypotenuse, which is 6. Cross multiply. W equals 6 times sine of 30. Sine of 30 in your calculators, I believe, is 0.5 or 1/2, and you'll get W to equal 3, which I just got, right? And to solve for X, X is on the inside, so therefore, class, is it an angle or side? It's an angle. So from this angle, I have the adjacent over the hypotenuse. That would give us cosine. So cosine of X equals 3 over 4. If I go ahead and take the inverse, I have the inverse of cosine of 3/4 equals X. It tells us to round to the nearest degree, so X is going to be approximately, still check, approximately 41 degrees. Let's use red. Nearest tenth, and each answer to the nearest degree. Notice here if I put my finger over 56 degrees and W, the common mistake here is, see if you made the mistake, is that the big triangle is not 34 degrees 10 and X. The big triangle would be 34 degrees 10 and W plus X. Raise your hand if you saw that. Here's my explanation of why X is not the full length. If I cover it up, class, is that a right triangle? No, it's an obtuse scalene. So you can't apply trigonometry to this part. Does that make sense? Also, you should recognize that you only have an angle in a side anyways. You would have to use more advanced trigonometry like law of sines and cosines. So the first thing I'm going to do is I'm going to solve for the small triangle. If you want to, you can separate it by colors. So here I have 10 W and 56 degrees. Ruby, which trig ratio did you use here? Tangent is correct. So start with the angle, label your sides, opposite, cross the right angle is always the hypotenuse, and then you have the adjacent, and you're using SOHCAHTOA. We don't have the hypotenuse, so you can cross off everything that has the h. Now you have TOA, which means tangent of our angle. So you're always putting an angle next to the trig ratio. And then over here you have sides. My sides are opposite over the adjacent, so 10 over W. Sophie, what do I do here for the next step? We're going to cross multiply, so I'm going to make this a fraction. So I have W times tangent of 56 degrees. If you're even getting stuck on this part here, you could put a parentheses around tangent of 56. It's kind of like 1 unit. Some of you might be kind of like stuck, like, is it 2? Like, is tangent one thing and 56 a different thing? They're together. It's like a dating couple, right? You got to take them together. You can't break them up. And then I'm going to divide by tangent of 56 on both sides. So cancel. You have your calculator ready equation. W equals tangent of 10 over tangent of 56. Let's put it in. Make sure you're on degree mode. Extra set of parentheses. 10 divided by tangent of 56. Raise your hand if you got approximately 6.745. Now remember, although up here it says round to the nearest tenth, I'm actually going to leave those numbers. I guess you could use approximately what? 6.7. The only reason why I'm considering keeping more decimals, just in case, like maybe I not trick you, but a more difficult problem would be something like this. Solve for the variable x. Do you see that? If I took away w, it's implied that I need to solve for this length first, then use that to solve for x. Okay? But here they're kind of guiding you by making you solve for, recognizing you do have a variable here, solve for w first, then x. All right, let's go ahead and solve for x now. Use your favorite color. So I have 10, 34, and w plus x. So we're going to use which trig ratio class? Tangent, you have the opposite side over the adjacent side. So I have tangent of 34 degrees equals the opposite 10 over w plus x. At any time you can actually do the substitution. I'm just waiting till the very end. Cross multiply. W plus x. They're together. Don't break them up. Tangent of 34 degrees equals 10. Okay. First thing I'm going to do here is divide by tangent of 34. So now I'm left with w plus x equals 10 over tangent of 34. And then I'm trying to solve for x, so I can just subtract w. X. Is that nice? You have a really nice calculator-ready equation problem. 10 over tangent of 34 degrees minus our 6.7. So again, at any time for w, you could have substituted it in there. But I waited till the very end. 6.7. Let's put that into our calculators. Now, be careful here. You're not doing something crazy like 10 minus 6.7. You got to treat them as expressions. 10 over tangent of 34. Whatever your answer is, subtracted from 6.7. Remember in your calculators, there's a trick. If you want to do copy and paste from the previous expression, I'm just going to press second and enter. That means the entry. And I can just go back and change that number. So there I get something like x is approximately 14.825. 14.825. Or I could just take my answer and minus from 6.7. And you get approximately, subtracting from 6.7, and I get approximately 8.1. Raise your hand if you got that answer. If two sides of a triangle are the same, what type of triangle do you have? Well, you would make these marks, and you would have a what? You have an isosceles triangle. An isosceles triangle basically says the sides are the same, and their base angles are the same. So you can write 42 degrees right here. I'm going to go ahead and solve for W. You can solve using any triangle. I have the opposite side. I have the hypotenuse because it's across the right angle. Class, which trig function am I going to use? Sine. Sine of 42 degrees is equal to W over 102. How do I make this a fraction? And then what do I do after that? Cross multiply. So now I have W equals sine of 42 times 102. Parentheses, sine 42, close, close, 102. And although it tells us to round to the nearest whole, I would not do that right now. Oh, it says round each side length to the nearest tenth in the directions. You guys see that? But remember, this time we can, so that would be what? 68.3. So W is approximately 68.3 units. Raise your hand if you got that. Okay, there's a couple of ways of solving the next problem. Now, here's a question. On the big triangle, let me highlight that for you in yellow. Talk to your partner. Can you use trigonometry? Can you use SOHCAHTOA? Raise your hand yes. Raise your hand no. Okay, the answer is no. For a right triangle, you can use SOHCAHTOA. You can use the trig ratios. This looks like a right triangle, but it is not 90 degrees. Because if this was 90 plus 42 gives you 174. Can a triangle and all of its sum equal 174? That should equal what number, class? So I have 180 minus 42 minus 42, and that angle is 96 degrees. What does that mean, that this is 96 degrees? It means that in the yellow triangle, you cannot use trigonometry. You cannot use 42 equals opposite over the hypotenuse. That would be incorrect. Because trig only works with what type of triangles? Right. And the yellow one is? Not a right triangle. Okay? So what can you do? Well, we can say that this is 0.5x, or half of x, and we can say that this is half of x. The reason why you can say that is more geometry, perpendicular bisector. But basically just think this is whole length is x, and I can break it in half. I can use this triangle and solve for half of x, and then that will tell us what the whole value of x is. So from here, I want to use 0.5x and 102, so this would be the adjacent side. And this one would be the hypotenuse. I have 0.5, or I have adjacent and the hypotenuse. Class, on the count of three, we're going to say the trig ratio. 1, 2, 3. Cosine. So if you didn't write this phrase on top of your last quiz, you might want to do that. And we are not going to use W, so I'm not using the opposite side of 42 degrees, so I can cancel out all of those that have O. And that's why we're using cosine. Now, you always write cosine with an angle. Or, you always write a trig ratio with an angle. So I have cosine of 42 degrees. Our adjacent side is 0.5x. And the hypotenuse is 102. Class, how do I solve for x? Cross multiply. So I have 0.5x equals cosine of 42 degrees times 102. Let's multiply these two first. So now I have cosine of 42 times 102. And you get 75.800072. And if I divide both sides by 0.5, you get that x is approximately 51.6. And for sides, I believe you're rounding to the nearest tenths. And this is our answer. And one alternative way of solving this problem. Nope, that wouldn't work. So this is our only solution. Wants to see a castle in an amusement park. So I'm just going to draw Leah. And let's draw a castle. Oh man, looks more like a tower. Totally fine. Draw the ground. Leah wants to see a castle in an amusement park. She cites the top of the castle at angle of elevation to be 38 degrees. So it looks like a simple, direct problem. And the angle of elevation, remember, it's her line of sight looking and then going up elevation like an elevator, 38 degrees. She knows that the castle is 190 feet tall. So I'm going to have to redraw my picture. If Leah is 5.5 feet tall, so if Leah's like this, right? How far is she away from the castle? So they kind of want to know. This is now the ground. That would be x. So I'll draw this down here. So if Leah is 5.5 feet, so this kind of tells me then the castle is, my castle's going to go further down. So the whole castle is 190. And basically what we're going to do is, although we're solving for this side, this would be x. The castle itself is 190 feet. So let's put that up here, 190 feet. And this is 5.5, so the question is, what is just this portion of the castle, which is, if you did segment addition, let's do a quick one over here. So the whole, 190 equals the part plus the part, so y plus 5.5. So if I subtract 5.5 from both sides, I'm going to get 184.5. So that means the length in the, I'm just talking about this length. So now if I do my problem, I have 38 degrees. My opposite side, which is the 184.5. And then I have the adjacent, which is my x. I'm going to have tangent of 38 degrees equals the opposite over the adjacent. So I'll be tangent of 38 degrees equals 184.5 all over the x. To solve that, I'm going to go ahead and put it over 1 and then cross multiply. So I have x times tangent of 38 degrees equals 184.5. And then if I divide both sides by tangent of 38, my calculator equation is x equals this number. Tells us round to the nearest foot, so let's go ahead and divide. Extra set of parentheses, 184.5 divided by tangent of 30. And, sorry, that should be tangent of 38. Let's try that again. So if you make a mistake like I did, want to copy and paste your calculator command, you can get entry. You do that by doing second enter. And then I can just go back and change that 8. That gives me approximately 236. Remember, it's to the nearest or whole foot. And this would be our answer. Let me go back and change those to be 38s. Yeah. So Leah is approximately 236 feet away from the castle. I'm thinking to myself, where's the lifeguard, right? A lifeguard is watching a beach from a line of sight 6 feet above the ground. So I was thinking, okay, lifeguards are usually on their lifeguard towers, right? That's how you find your friends at the beach. I guess you guys use your phones these days, huh? So there's my lifeguard. That was 6 feet. And then line of sight. Remember, if you get stuck on a word problem, just draw a right triangle. You already know we're focusing on that, so you know it's going to happen. A lifeguard is watching a beach. So this is the beach, maybe like, let's see what happens. From a line of sight 6 feet above the ground. So they're actually in the lifeguard station. She sees a swimmer Oh, I didn't study for my quiz. She sees a swimmer at an angle of depression of 8 degrees. Remember, the lifeguard is not doing their job. They're kind of just looking at the horizon or out in the ocean, and then they look down for the angle of depression. So this angle, let's see if we can color code that. The angle of depression is 8 degrees. That's too big of a degree sign. How far away from the tower is the swimmer? Okay. Here are a couple of implications for this problem. I don't think they're clear enough in their question. So I would try to put a qualifying, what do you guys call it in English? Descriptive, more adjective? From the base of the tower. Is that more clear? Were you thinking that? Like, anyone thinking this way? Because if that was there, then I would say, like, how far away is the lifeguard, she, away from the swimmer? Like, maybe she's like Captain Marvel, right? And then she can just fly out from the tower directly, right? Most people have to go down the tower and then run. So if I write the words, how far away is the swimmer from the base of the tower? This is the base and this is the swimmer, so then we would put X here. Okay, couple of suggestions as you're doing that problem. Remember, the angle of depression is equal to the angle of elevation. So raise your hand if you wrote 8 degrees in here. That is one way of doing the problem, and it's perfectly fine. Raise your hand if you did complementary angles. Well, 8 degrees, 90 minus 8 is how much? So you can write 82 degrees up here. Raise your hand if you did that. Totally okay. It's a little bit more work, but you can also draw a triangle up here and just move everything over. 6 feet, and then you can put X up here. Raise your hand if you did that. So I wanted to show that there's multiple ways of solving the same problem. I'll do this problem. Let's try a little bit different. I'm going to move the 8 degrees over here. Alternate interior angles are congruent. And so let me highlight the triangle I'm going to use. So even if your picture is kind of all messy, it's okay to just take your picture, your triangle, and then just redraw it. Good idea. I wasn't throwing it at you. So 8 degrees, 6, and X. Seems like your favorite trig function. Tangent, 8 degrees, opposite over the adjacent, so 6 over X. You're going to cross multiply. You'll get tangent of 8 degrees times X equals 6. Divide by tangent of 8 on both sides. And you have a calculator-ready equation there. And whatever triangle you used over there, we should get the same answer. Let's try it. 6 divided by tangent of 8 degrees. And you should get approximately, to the nearest foot, 43 feet. Raise your hand if you got that. Awesome.
I love math. You don't love math? What's wrong with you? I love math.
Buildings are sited from on top of a 200-meter skyscraper. All right, so here are my 2 buildings. These are the tops of them, right? Because imagine that's like building A, and it's like building B. So there's A. That's the corner of building A, and this is the corner of building B. And then my skyscraper has to be taller, right? They call it a skyscraper because it scrapes or touches the sky. So it's like way up here. Skyscraper. Two buildings are sighted from on top. So there you are on top of the world, getting almost a perfect on that quiz. Building A is sighted at an angle of 35 degrees, a 35-degree angle of depression. So remember, you are drawing your line of sight. So you're looking out there, you're daydreaming. I wonder if I rounded correctly, I could have gotten a perfect. The only perfect out of 2 classes. And then if you look down at A, this is 35 degrees. While B is sighted at an angle of 36 degrees. So hopefully you can note by colors, this is 36 degrees. How far apart are the 2 buildings in the nearest meter? So let's try to make that a color. They want to know that length. So if you think about the problem, you're not really concerned about, okay, this is like ground level way down here. You're not really concerned about that. You're just worried about the tops because you're making this triangle, and you're just worried about this distance here. So we're like really floating up into space, aren't we? You actually don't even need to go to the ground level. So that's what my picture looks like. So class, after this, you're going to make 2 triangles. So in the yellow, my angle is out here 36 degrees. I have an unknown length. Our skyscraper is 200. Maybe these buildings aren't very tall. I don't know. Maybe this would be a better example. Like, this is the ground level, therefore this is 200. That makes more sense, huh?
Yeah.
200. What letter do you guys want to call this one? J? Okay, let me do a quick think out loud. Is it blurry? You guys can say that. Raise your hand if you use complementary angles. How much is this angle then? 54 degrees. Raise your hand if you use alternate interior angles. Say this one's 36. What I'm trying to do is show you that there's multiple ways of getting an angle inside the yellow triangle. So remember, the angle of elevation is the same thing as the angle of depression. Another way you can do the problem is you can draw the triangle this way and just copy all your information over here. 200, and then put that one as J. Raise your hand if you did that. So I'm trying to show you guys multiple ways. I'll use complementary angles. So 36 plus something equals 90. That number is what again? 54 degrees. And then you can just go about solving for J. Let's use our green. Okay, here's the common mistake for the green. Class, this side is how much? 200. What variable you guys want to call this one? It's making it complicated. K. Now, class, is this one K? So the common mistake is to put K here. Why K is wrong? Because K is only a scalene triangle. That's that distance. Does that make sense? It's not a right triangle. J plus K is the whole length. And then you have the same thing. That was 35 degrees. And so you can use complementary angles, or you can use alternary angles. Let's use alternary angles. Let's say this one's 35. And then someone kind of shouted out loud, then when we use segment addition, so we have one triangle, we did two triangles, and then next, in this problem, we don't have to solve and set them equal to each other. The reason why we don't have to do that is we're not solving for this length. Because once you solve for j, you can actually put it in here. Does that make sense? So in this problem, you can use segment addition, and you can say j plus k equals, someone said L. L equals j plus k. Degrees, so that is the opposite side. That's the hypotenuse. This is the adjacent. So which trig function, class? Tangent of 54 degrees equals the j over 200. I'm going to cross multiply. So I get j equals tangent of 54 degrees times 200. There's my calculator ready equation. Extra set of parentheses, so tangent 54, close, close. Remember, although it says to the nearest meter, I'm not going to round here. $275.28. Raise your hand if you got that. I'm going to box it. It's an answer. Now I'm going to go ahead and input from here. I have the opposite over, oh wait, what am I doing? Opposite over the adjacent. So that'd be tangent of 35 equals 200 over j plus k. Cross multiply, I get 200 equals tangent of 35 of j plus k. Okay, pay attention here. In the previous problem that we did on Friday, you might be tempted to multiply or distribute. I'm not going to do that because I have a known length for j. Do you see the difference? So what I'm going to do is I'm going to divide both sides by tangent of 35. Some of you guys are being like robotic in your math. You just want to know steps, but you're not thinking why you're doing that. That's the more important part. So I have tangent of 200 over tangent of 35. And then now I have just j plus k. And I'm trying to solve for k, which means I can just subtract j from both sides. So my calculator ready equation is 200 over tangent of 35, which you can get some numbers. We will do it together. And then you subtract j, and you get your answer of k. So k will be approximately something. So let's do that. Tangent Well, that's fine. 200 divided by, use extra set of parentheses. 200, you can't see that. 200, yeah, you. Correct. Alright, I'll go back and I could have just made it L. That probably would have been easier, huh? 200 divided by tangent 35. That gives me 285. And then I just subtract J, which is 275.28. So 285.63 minus 275.28. What? Try that again, Mr. Ray. 285.63 minus 275.28. And I get approximately 10. 10 feet. Now, as we had said, it probably would have been easier in this problem if instead of Jocelyn's yelling at me, I should have used L if she had repeated 50 times. This should have just been L. Does that make sense? And then you could have subtracted it from up here. You would have gone 275 plus 0.28 plus K equals L, and L would have been the tangent of opposite tangent J plus K. That would have just been equal to 285, right? And then if you subtract it, then you would have gotten the same thing, K equals approximately 10. All right, so let's review. Draw one triangle, separate it, and then you could use segment addition and get an answer.
I love math. You don't love math? What's wrong with you? I love math. You don't love math? What's wrong with you? I love math.
To estimate the height of a tree, she, I don't know who that is, she, Mrs. Long, so let's draw Mrs. Long, cites the tree so again, if you're getting stuck on the word problems, just draw a right triangle. Now you might be asking, how come I didn't draw the triangle from her feet? And I am accounting for this. Mrs. Long cites the tree at the top with a 70-degree angle of elevation. So it's going up, but again, I'm not drawing 70 degrees here. Wait till I finish reading. She then steps back 10 meters and cites the top of it to the top at now 26 degrees. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree in meters? So we're asked to find the height of the tree. Now it gives us some kind of information that's kind of new to us. Mrs. Long's line of sight is 1.7 meters. What does that mean? She is 1.7 meters tall. And so basically the triangle starts from her eyes. So draw the line of sight. We want to know the height of the tree. Well, when you solve for the right triangle, you're going to have this pink right here, but you're going to have to add 1.7 when you're done. So let's go back and look at some information. To estimate the height of a tree she wants removed, Mrs. Long cites the top of the tree, so she probably originally starts here and looks up, and the tree is at 70 degrees. Of elevation. She then steps back 10 meters. So this length here is 10 meters. And now the sight to the top of the tree is now 26 degrees. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree? So this is your picture. I have this distance from where she started to the tree. I'm going to call this one X. This distance over here, before we call that height, I'm just going to call it Y for now. The reason why is because I want to call this one the height. So let's go ahead and draw our two triangles. Pick your favorite color. So here's our first triangle. I have the side Y, I have the side X, and I have 70 degrees. If I draw the blue triangle, in the blue triangle, I have the side Y. Here, I'm going to have 10 plus X. And then I have 26 degrees. So this should tell you from Friday's lesson, the hint is if you look at both triangles, what's the same? Although you have an X, this X is not by itself, so it's just easiest if I solve both of these in terms of Y. Let's just do that together, because the cockroach cut short our time. Class, what's trig ratio? Tangent of 70 degrees equals the opposite over the adjacent, which is y over x. I want to get y by itself, so I'm going to cross multiply. I have x times tangent of 70 equals y. So here's my answer in terms of y. We're going to do the same thing on this side. So I have opposite over the adjacent, so I have tangent of 26 degrees because I have OA, opposite over the adjacent. Remember, keep the 10 plus x together. They're a dating couple. You don't want to break them apart. So now I have 10 plus x times tangent of 26 degrees equals y. So now I have two triangles that are set equal to the same variable. So we can write that. Solve for y, which we did. Let's now set equal to each other. Set equal to each other. So basically, I'm going to have the yellow equal to the blue. And hopefully I'll show you again why this works. X times tangent of 70 degrees equals y. And this one also says y equals 10 plus x times tangent of 26. Since they're both equal to y, you don't need that anymore. They're equal to each other. I'm going to keep this side the same. Here, this is where I'm going to distribute. And the reason why I have to distribute is that I want to get the x's by itself so I can solve for the variable x. So here I'm going to have 10 times tangent of 26 plus x times tangent of 26. Remember, if you want to go back to this step here, you're just factoring out tangent of 26 as your greatest common factor. I'm going to get the x's together. So now I'm going to subtract x times tangent of 26 from both sides. And now I'm left with x times tangent of 70 minus x times tangent of 26 equals, this cancels, 10 times tangent of 26 I'm going to factor out an x. X times the tangent of 70 degrees minus the tangent of 26 degrees equals the same. Remember, do not be tempted to subtract 70 minus 26 to get something like 44, tangent of 44. That would be wrong. These are evaluated separately. But I want to get x by itself, so this is multiplication. So I'm going to divide both sides by tangent of 70 minus 26. These expressions will cancel, and then I'm left with a calculator-ready equation. I'm going to evaluate these separately, so I'm going to do the numerator and get a decimal. So 10 times the tangent of 26 4.8773. Remember, although it tells me to round to, does it tell me to round? Nearest meter. I'm not going to do that till the very end. Tangent of 70 minus the tangent of 26. Now, notice my mistake here. This is subtracting the two angles. I need to subtract 70 degrees minus tangent of 26. So tangent of 26. Gives me 2.2597. I'm now going to divide those two problems. I get approximately 2.158. Let's look back up to our problem. 2.158 only represents this distance. Push back your desks. Have a good day. can use one of these formulas, which I'll probably use this one right here. Copy that, so it just says, that was my yellow box. And what I'm trying to do there now is solve for the length of W. So 2.158 times tangent of 70 degrees will give me approximately y. So we can say that y is approximately 2.158 times tangent of 70. And I get approximately 5.93. Okay, now that I have y, ran out of space here, but you can do something like a segment addition. In segment addition postulate, here I have y plus 1.7 equals h. And so the y variable is equal to 5.93. So then if I add this together, and then I round to the nearest meter, so 5.93 plus 1.7, and then I round to the nearest meter, and then I get 7.63. Then rounded, that would give me like approximately 8 meters. So definitely a long problem. Draw your picture. One triangle, try to separate into two. In this problem, because you're solving on this side, it's a system of equations because you have two unknowns, w and x. So you can set them equal to each other and solve. Remember, x is not your final answer. X is only this length. Put it into one of these formulas to solve for y. And then once you have that y value, then you're trying to add it to the 1.7 meters. That's her eye level. So basically, whatever's above her eye level plus 1.7 gives you the height of the tree, which is approximately 8 meters.